Okay, 5.3D says represent multiplication of decimals with products to the hundredths using objects and pictorial models, including area models. And then 5.3E, solve for products of decimals to the hundredths, including situations involving money, using strategies based on place value understandings, properties of operations, and the relationship to the multiplication of whole numbers. So that's a lot in there, but I'm going to touch base on a little bit of that here. So first of all, with representing multiplication of decimals, really there's some different distinctions within that. So I've just written down some possibilities here where we have a whole number times a decimal that's less than one whole, and then we have two decimals, both of them are less than one whole, so less than one whole times less than one whole, and then we have two decimals that are both greater than or equal to one whole. So these are three different situations and can be represented differently. So starting with this first one here, this 3 times 5/10, so it's a whole number times a decimal, or a whole number times a part. I always tell my kids, think about this as three groups of 5/10. And when we think repeated addition, it would be 5/10 plus 5/10 plus 5/10, which we would represent 5/10 plus 5/10 plus 5/10 if we're lining them up like that, okay? So if I were doing that with base 10 blocks, for example, the thing we always have to do with base 10 blocks is establish what's our whole. So if I'm only working with tenths and hundredths as I do in multiplication in 5th grade, then I'm going to let this be my one whole. Okay, so if that's my one whole, those are tenths and those are hundredths. So we just establish that first. So if I have 3 times 5/10 or 3 groups of 5/10, then I would say, much like I did with whole number multiplication, there's a group of 5/10, there's 2 groups of 5/10, there's 3 groups of 5/10. So when I put that together, I get 5, 10, 15 tenths. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those make one whole. So one whole and 5/10. So that's how you would do it with your base 10 blocks if it's a whole number times a decimal. And of course, when you add this 5, 10, 15, that adds up to 15. And remember that decimal point comes straight down, which is your one whole and 5/10. Okay, so we might represent that using a piece of grid paper. So for that problem, 3 times 5/10, when I get ready to do this on the grid paper, I would shade in one group of 5/10, two groups of 5/10, and that's not showing up, and then a third group of 5/10. And when you put all that together, you see one whole and 5/10. So take your kids through the paces there. Do it with the base 10 blocks. Do it with the grid paper there. So the final part of that 3 times 5/10, of course, is the actual multiplication there. And then they multiply, ignoring the decimal at first. 3 times 5 is 15. And then they count in, okay, I had no decimal here, and I had 1 digit behind the decimal there, so I move in a total of 1 places, and we get our 1 and 5/10. But you don't want to get to that until you've done all of the pictorial and manipulative teaching of that, because otherwise that doesn't even make sense that I move in 1 place. Okay, so this next one here is the 3/10 times 5/10. And this is the one that it's easy to do and it's easy to show, but it's such an abstract thing, like what is happening here. And so one of the things that I really stress is, when we talk about multiplication being groups of, this is not a whole group, and that's not a whole group. So I can't say 3 groups of 5. I can't even say 3 groups of 5/10. I have to say a part of a part. This is 3/10 of 5/10. We use that word of in there. 3/10 of 5/10. So 3/10 of 5/10. So if these are representing my 5/10, okay, 1/10, 2/10, 3/10, 4/10, 5/10, but I don't want all of this. I don't want 3 groups of this. I don't even want 1 group of this. I only want 3/10 of this group. So the nice thing about these base 10 blocks is they're broken up into these little 10 pieces here, right? So you can say, well, I only want, let me use something to cover that up so you can see what I'm talking about here. I only want, that would be 1/10 of my 5/10. This would be 2/10, and this would be 3/10, because this was, 3/10 of this one, 3/10 of this one, 3/10 of this one, 3/10 of this one, and 3/10 of that one. So what I get is 3, 6, 9, 12, 15, but it's not 15/10, it's 15 hundredths when you think about it that way. Because really you're looking at, here was my whole, these are tenths, and then when I cut back the other way, I get hundredths. So 1, 2, 3, 4, 5. Here's my group of 5/10, and then I only wanted 3/10 of that, which is 15 hundredths. Man, that's interesting. Okay, so let's do that here with our little grids. So when you do it with the little grids, and it's always nice to have the contrasting highlighters. So 3/10 of 5/10 means I want to start with 5/10 highlighted. So 1, 2, 3, 4, 5. There is my 5/10. Now, the columns are tenths, but when you look at all of it, we actually have hundredths there, right? So that's 5/10. And now I want 3/10 of that. So going back the other way, I'm just going to highlight across 3/10. So 1/10, 2/10, 3/10. And then what happens so nicely for us there is that the yellow and blue make green. And so the green part is actually our 3/10 of the 5/10 we had. We highlighted that because we were just doing 3/10 going this way, but really this was our original 5/10, and now the green part there is the 3/10 of that 5/10, which is our answer, and it's the 15 hundredths. So to see that on a test, you're going to see a picture something like this, where they've highlighted one factor one way, and the other factor the other way, and then the overlap is your answer. So that leaves the last way of doing the multiplication, where you have something like the 1 3/10 times 2 4/10. And if you've already used the base 10 blocks to teach whole numbers, multiplication of whole numbers, then this is really, really nice, because it's going to look very much like that. You just have to have that whole discussion about, now we're using a different one, a different whole. So when I go to represent 1 3/10 times 2 4/10, 1 3/10 times 2 4/10. This is one whole. But when we do that, when we do the array like we did with whole numbers, going across here will be one factor and going across here will be another. So we're not going to use one of these. We'll use this going this way to represent 1 and 1, 2, 3 tenths times 2 and 4 tenths. So much like we did with whole number multiplication, is we're going to fill in our array so that it makes a rectangle here. And so if we say this times this gives us this. And I've got another one here. So what I'm saying here is 1 whole times 2 wholes is 2 wholes. And I know this isn't a whole here, but remember we're only representing that edge of it, right? So 1 times 2 is 2 wholes. And then 1 whole times 3 tenths it's actually 2 wholes times 3 tenths, which is what's going to give us 6 tenths here. And then 1 whole times 4 tenths here is 4 tenths, going that way. And then 3 tenths times 4 tenths gives us 12 hundredths, which is what we're going to fill in here, right there. And the wording of that can get very confusing, but if they look at this just like they did with our whole number multiplication, it looks almost exactly the same. And we're going to pull this apart because that was the original factors over there. Okay, now we're going to just count this up. So this is 1 whole, 2 wholes, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths actually makes a 3rd whole. So this is now 3 wholes. And 3, 6, 9, 10 of those makes a 10th. And then there's 2 hundredths left over. So that's what it would look like with your base 10 blocks. So then when you take the same problem, so 1 and 3 tenths times 2 and 4 tenths. If you break it down into partial products, like we did with whole number multiplication, okay, now this gets very tricky, so you be careful with your kids here. 3 tenths times 4 tenths is 12 hundredths, okay? 1 whole times 4 tenths is 4 tenths. Notice I'm lining up my decimal there. 4 tenths is the same thing as 40 hundredths. You can make that connection, all right? And then 2 wholes times 3 tenths is 6 tenths, or 60 hundredths. And 2 wholes times 1 whole is 2 wholes, which goes out there. And then you're going to add all of that up. 2, 11, 3. You get the same answer. But be really careful if you're doing that. Yes, that's the same, and that's the whole properties of multiplication and the relationship of multiplication addition, but you got to be really careful right here with your lining up. Okay? And that all goes back to the same thing like we did with multiplication of whole numbers. When you get ready to do standard algorithm, we say ignore the decimals, just multiply. 3 times 4 is 12. 4 times 1 is 4, plus 1 more is 5. I tell my kids, scratch, scratch, lay an egg. We lay an egg to hold that place, because when we move over here, we're actually going to be, this is in the 1 holds place instead of the tenths place. This is 2 times 3 is 6. 2 times 1 is 2. And then you add, and then you have to count in your decimals when you do standard algorithm. There's 1 digit behind the decimal here, 1 digit behind the decimal there, for a total of 2 digits behind the decimal. So in our product, we come in 2 digits behind the decimal. Sorry, you weren't seeing that there. All very much like it was with whole number multiplication, as is the box method when you do so this was 2 4/10. Remember, we broke it up and did it like this. So, same situation. 2 times 1 is 2. 2 times 3/10 is 6/10. 4/10 times 1 whole is 4/10. And 4/10 times 3/10 is 12 hundredths. And then when you add that up, you have to be very careful. And then our 2 holes out here. And you get the same answer, okay? So, multiplication of decimals, decimal times whole, greater than whole times greater times whole, all look very differently. So you kind of have to walk across that process with your kids. When you get to this, where it's the greater than 1 times greater than 1, it looks very much like whole number multiplication did, and you can go through all the same processes, just making sure they get that decimal in there.